Two polar regions here, and we're asked to find the area of the region inside the curve C1 but outside C2. In fact, to show that it's p root 3 minus q pi, like it. So how are we going to do this? It's going to be an integration. Now, if we could find out where the two curves intersect, the value of theta, that's what we're going to do in a second, then we could perform two integrations. We could first of all integrate between these two angles and work out this entire little region. That is for C1, let me just say. And then with the same lines drawn, I could integrate C2 and find the area between this region, and that would give me this tiny little bit. And so if I do the blue region minus the red region, I will get the shaded region that I want. That's where we're headed in this question. So we need to set the curves equal to one another. When do they have the same radius? It's going to be when 1 plus sine theta is equal to 3 minus 3 sine theta. Just set them equal and expanded that second bracket. That means 4 sine theta is going to equal 2, and sine theta is going to equal a half. Let's do inverse sine. We get pi over 6, or pi minus pi over 6, 5 pi over 6. Okay, so that little angle there is pi over 6. That's going to be my first limit for my integration. And then it's going to be, I'm just trying to, that angle there is going to be 5 pi over 6. So if I want to find the blue area, then it's going to be a half integral r squared d theta. Remember, we're basically finding a small little sector. That's our half r squared d theta, and then we're summing it all up. And we're going to be integrating between pi over 6 and 5 pi over 6. That will give us that blue area. And then we're going to be doing exactly the same thing over here. It's just a different r. Same limits. But I'll just call this one like r2 and this one r1. And then we're going to subtract them. So let's do it. So I can actually write it as a single integral now. Integral from pi over 6 to 5 pi over 6 of r1 squared minus r2 squared. Now r1, I'm dealing with C1 first. It's going to be 1 plus sine theta squared. In brackets, that is. And then I'm going to be minusing 3, 1 minus sine theta squared. So that becomes 9, 1 minus sine theta all squared. Like it. Let's expand the bracket. 1 plus sine squared theta plus 2 sine theta minus 9, 1 plus sine squared theta minus 2 sine theta. I'll just do another line. 1 plus sine squared theta plus 2 sine theta minus 9 sine squared theta plus 18 sine theta. And then we get 1 minus 9, so that's minus 8. 2 sine theta plus 18 sine theta gives us plus 20 sine theta. And sine squared minus 9 squared, sorry, sine squared minus 9 sine squared is going to give us minus 8 sine squared theta. Okay. First two are simple to integrate. the sine squared, a little bit more involved, but it's one that you should have seen many a time by now as you practice in. We're going to use double angle formulae. Cos 2a is cos squared a minus sine squared a. Replace cos squared by 1 minus sine squared. We get 1 minus 2 sine squared a. Rearrange. I'm actually not going to find sine squared. I'm going to find 2 sine squared a. That's going to be 1 minus cos 2a. And I want 8. So 8 sine squared a is going to be 4 minus 4 cos 2a. So I'm going to be minusing 4, which is actually going to give me minus 12. Just combined it with the minus 8. Then I'm going to be minusing minus 4 cos 2 theta. So it's going to become plus 4 cos 2 theta. All right, we've had to do quite a bit there, but we finally got to a situation where we can integrate. And I'm just going to leave the half out. Of course, we could times through by half. Let's just do it at the end, I think. So I'm going to get minus 12 theta. And then sine theta integrates to minus cos theta. So I'm going to get minus 20 cos theta. Then cos theta will go to sine 2 theta. But then I need to divide through by 2. It will stay positive though. Remember, you can just differentiate back and check that it works using the chain rule. But that is going to be fine. All right, time to sub in. Minus 12 pi times pi over 6 becomes minus 10 pi. Then cos of pi over 6 is minus 3 over 2. Times that by minus 20 gives us plus 10 root 3. And then sine, it's going to be sine of 10 pi over 6. That is minus root 3 over 2. Times it by 2, we're going to get a minus root 3. That's by subbing in the first limit. And then I'm going to minus, right now I'm going to sub in pi over 6. I'm going to get minus 12 times pi over 6 is going to become minus 2 pi. Find cos of pi over 6, that is root 3 over 2, times it by 20, you get minus 10 root 3. And then sine of pi over 3 is root 3 over 2, times it by 2, we're going to get root 3, which we're adding here, plus root 3. So that's a half. And then minus 10 pi plus 2 pi is going to be minus 8 pi. Then we've got a lot of 10 root 3s. We've got 9 root 3 here. And then I'm minusing minus 9 root 3. So actually it's going to become 18 root 3. And then we're there. It's going to be 9 root 3 minus 4 pi. That is the enclosed area. Awesome. Don't really know. I didn't like enclosed area. There we are.